Hello student, today we are going to teach about the introduction of trigonometry. Okay, now trigonometry means the study of triangles, mean the measure of what? Of a triangles. Triangle plus geometry we call as trigonometry, and triangle mainly we study about right angle triangles. Then right angle triangles mean everyone knows that we study in class 9 below, class 8, class 7 study right angle triangle. When there is a one angle, interior angle is 90 degree, then that will be called as a right angle triangle. Now look, this one also 90 degree, then this one also 90 degree, then this will be, all these are right angle triangle. But this one is right angle at A, then this one is right angle at B, then this one is right angle at C. Remember, whenever we put the angle 90 degree, always mention this right angle at A or B or C, so that you won't be confused which one is the hypotenuse, which one will be the perpendicular, and which one will be the base. Now this H, which is always opposite to H hypotenuse, this H stands for hypotenuse. Now this hypotenuse is always opposite to 90 degree. Then here also hypotenuse is here because it is opposite to 90 degree. And here also this hypotenuse H here is opposite to 90 degree. Remember, hypotenuse is always opposite to 90 degree. And perpendicular, this one, and base will be this one. This is up to your class 9 that always the line which is horizontal you put as a base before. But now in class 10 this will be changed because it depends on what? On the angle. Depends on this. Depends on the angles. If here is the angle, then this one will be changed to perpendicular. Okay, we will look about that later. And no, remember that hypotenuse is always greater than perpendicular. Look this one. Hypotenuse is always greater than perpendicular, and hypotenuse is always greater than base. This one. Now let's look at the definition of trigonometry. Trigonometry is the branch of mathematics which deals with the study of the relation between the side and the angles. The relation between the side angles of a triangles. Mean this angle and this side, what is their relation? Then this angle and this side, what is their relation? Then this angle and this side, what's the relation? That in this chapter we'll look about that relation. Then before we'll go forward, first we have to know what is ratio. We need to understand the meaning of ratio there. Now before we go on, we have to know what's the meaning of ratio. Look, ratio you already studied in class 7, class 8. You already studied a separate chapter, ratio and proportion. And what's the meaning of ratio? Mostly you write like this. 1:2. It is a ratio. Then sometimes you write this ratio as 1/2. 1:2, or you write 1/2 or 1:2. This will be the ratio example. Then you write generally A:B. But exactly I don't want this. I want the meaning. What's the meaning of ratio? This means the representation of this ratio. But we want the meaning of ratio. Ratio, the meaning means like this. Example, if I give, there are one tub. Okay, silent little tub. This one tub, and then another one tub. Now let's say the volume of this is V1 and the volume of this is V2. What's volume? Volume means the space or the size. Now let's say the volume of this is V1 and the volume of this is V2. But by looking to this figure, we can say the volume V1 is greater than volume V2. Now how much it is greater? Let's say this V1 is greater for V2 by how much? By 2 times. Okay, can write like this. V1 is equal to 2 times V2. 2 times V2 means how much this V1 is greater than V2? 2 times greater. Now if I take this V2 this side, then go like this. V1 by V2, then what left here? 2 is to 1. Now this is 2 is to 1. This we can write as 2 is to 1 is the ratio. Right? Then now what is this? What is the meaning of this now? V1 by V2 is equal to 2 is to 1. Mean the ratio is 2 is to 1. Then here we compare that V1 is greater than V2 by how much? By 2 times. Then ratio means the comparison. What's the meaning of ratio? Ratio means comparison. Comparison between who's big and who's small. Who's fat and who's thin. That will be called comparison. Then comparison will be in mathematics we can write as a ratio. Then here. Okay, I draw like this. Generally, this is the right angle triangle. Let's say here is a 90 degree. Then I put generally. This is obviously will be a hypotenuse because it's opposite to 90 degree. Then this will be the perpendicular. Then this will be the base. Now this side, it has a relation with the some angles. Okay, I will leave first at one. And look, now how to write a ratio here? Compare this base and hypotenuse. We want to compare this one and this one. Then hypotenuse and perpendicular. Then perpendicular and base. A comparison. Like that is. Perpendicular by hypotenuse. Is this a ratio? Yes, this is a ratio. Then base by hypotenuse. Base by hypotenuse. Then this also a ratio. And then perpendicular by base, this is also a ratio. Now if I interchange H by P, that also again a ratio. H by B, that also again a ratio. B by P is also again a ratio. Then it will be total how many ratio? There will be 6. This will be 3. Okay, here how many? 3 ratio. Then one more. If I interchange this one, H by P, then again this is still a ratio. Then again interchange this one. Then H by B, then again this is a ratio. Then again interchange this one. Then this will be B by P. This is also a ratio. Now this one will be 3. Then this one will be 3. Then how many ratio total? 6 ratio. Now these 6 ratios, they have their own names. And this ratio P by H, it has some values. And that values are related, are having a relation. The value of P by H has a relation with angles. Then this ratio has a relation with angles. This ratio is a ratio between a side P by H. A side between P by H. Now this P by H is the side and it has a relation with the angles. And that will be given by, we will look for that. Okay. Now let's look the relation between side and angles. Okay. Relation between side and angles. Okay. Now let's take this triangle. again here is a 90 degree. Now obviously when there is a 90 degree here, then this will be the hypotenuse. Now then we consider this one is the angle. Okay, angle is denoted with symbol theta generally. Angles denoted generally with theta, or sometimes with ABC alphabet. Okay. Now, with respect to this angle theta here, this will be the perpendicular, then this will be the base. The side, this one. The side which is always opposite to angle. The side which is always opposite to angle will be called as perpendicular. Okay, look here. Now, hypotenuse H is opposite to H is opposite to 90 degree, and P is opposite to angles. Then B is adjacent to angles. Okay. Now, if angle will be here, then with respect to this angle, this will be the perpendicular, then this will be the base. Now, if I change this theta here, if I put like this. Now again here will be 90 degree, then this will be obviously hypotenuse. Now if I put theta here, now this will be the angles. Now if I take this angle, now in this figure this will be the angle, then this will be the perpendicular. Now here this will be the angle, then this will be the perpendicular. No more like before. Now before we said when always there's a line horizontal, that always will be the base. But now if with respect to angles, if the side which is opposite to angles will be perpendicular, then this will be obviously will be the base. Now look here, P perpendicular is always opposite to angles. Look here, this P is opposite to angles, then this H is opposite to 90, then this B will be adjacent to theta. And don't confuse this. Okay, now come to next. Okay, relation between the side and angles. Okay, like this, P by H. This has a relation. This will be a ratio, right? Then this ratio has an equivalent number with angle. This angle theta. Then that will be called as sine theta. Now this sign here is not a mathematical word. It is simply a given name to this ratio. Sine here is just a given name for this ratio, because how many ratios? There are 6 ratios. Then that will be P by H. This is also a ratio. Then B by H. This is also a ratio. How many ratio? 6 ratio are there. Then this ratio is named as sine. The ratio of P by H is named as sine, so that it won't be confused, because all are ratio. Then we give this ratio as a particular name, sine. Then this ratio will be given as cosine. The next, P by H or P by B. Then this also is a ratio, and its name is tangent. They given a name. This is just a name. Now this sign, in short, we write only sin, but don't pronounce sins. It is a sine theta. Then P by H is equal to sine theta. Now this is the relation between the side and the angle. This angle is this theta is the angle. Now this P and H will be the side. Now this is the relation. Then P by H. Then B by H here is cosine. Then this we write in short cos theta. Then P by H, this is tangent. Then we write in short tan theta. Then inverse this or reciprocal of this, H by P. H by P, then this got a name of cosec theta. Then this reciprocal of this one, H by B. This is given as sec theta. The reciprocal of P by B, not P by H. P by B. Then the reciprocal of this, B by P, will be called as cot theta. Now all is coming 1, 2, 3, 4, 5, 6. Now this is called TR in short. TR means trigonometric ratio. Trigonometric ratios. Now do remember these formulas. Okay. Now this will be the formulas. P by H is equal to sin theta. You have to remember it. Then P by H. P stands for perpendicular. This one. Then H stands for hypotenuse. Perpendicular by hypotenuse will be sin theta. Base by hypotenuse will be cos theta. Then perpendicular by base will be tan theta. Remember at least these three, then this will come automatic. Because this P by H, now here is H by P. Just reverse of this or reciprocal of this. Then that H by P will be cosec theta. Then H by P, reversal of this cos theta. Then reciprocal of this also B by P will be cot theta. But there is a sentence, how to remember this one. At first, you make use of that sentence, but later it will be very easy for you to remember. Right now, maybe it's a new thing for you, it's difficult for you to remember. Okay, how to remember this one? I mean, most of the times we don't need to remember that one because obviously these are very simple, but at the beginning, maybe it's a confusion for you, then at least write this one. Remember. This sin theta, I can write like this. Some people have. Some people have. That's sin P by H. Some people have. Then here is cos. Purely, then B by H. Purely brown hair. Then this one, turn, this time, turn permanently black. Turn permanently black. Now this is for, remember this formula. At least remember these three, then this will come automatically because it's just reciprocal of these three. Now we'll do some problem related to this, but before we go to do the problem related to this trigonometric ratios, at least you have to remember the formulas of Pythagoras theorem. Okay, right? This one, this formula, we use it. And remember the name of this formula. This formula is called as trigonometric ratios. And how many of them? 6. 1, 2, 3, 4, 5, 6. Okay, now to make use of that TR, then we have one more formula, Pythagoras formula. This formula is, you'll get a proof of this formula in geometry. Proof of this formula. Proof in chapter 6. We will come across with this. But right now, we'll write Pythagoras formula. What's formula? Like this. Hypotenuse square equal to perpendicular square plus base square. In short, we have this. Now, h square equal to p square plus base square. Now we'll use this formula and together plus TR formula. Okay, this formula and this formula we'll use to come to do the exercise. Exercise 8A. Now in this chapter, exercise 8a means only these two formula are used. Pythagoras formula and trigonometric ratios formula. In short, we write as TR, and this one we write sometimes we call as PT, Pythagoras theorem. Okay, now we'll come to exercise 8a. MBOSE textbook. Okay, now before we come to this to exercise, okay, chapter 8, exercise 8a. Now before we come to this exercise 8a, okay, let me solve some question. I'll explain that question properly. Then after that, you try question number 1 from your exercise 8a. Okay. Okay. Now this will be the question. First I'll explain this question. Then once you understand this question, then you try from your textbook exercise 8a. Now in triangle ABC, right angle at B, okay, we'll draw the figure such that okay, this is given. Okay, but remember first this one. Sin theta. Please don't write like this. Sin into theta. Don't write like this. This is wrong. Because this sin theta is a ratio. Then if I write like this sin theta, then this theta is the angles. Then this is, what's the name of this side? Now this is just a name. This doesn't have a meaning. Then don't write sine into theta or sine into A. This is wrong. Always once we write sine A or cos A. Don't write cos into A or sine into theta. Always sine theta. Sine theta will be a one number. Then sine A also will be a one number. Then that number will be the ratio. Okay, remember this. I forgot to tell from the beginning. Okay, let's start this question. Okay, in triangle ABC, okay, let's draw this triangle. Right angle at what? Right angle at B. Okay. Let me draw this. Right angle at B. Okay, at B. Okay, find all the trigonometric ratios. The question is incomplete. Okay, I'll form it. Find all the trigonometric ratios of angle. Okay, of angle A and C. Of angle A and C, there will be 12 answers. Here will be 6 answers because there are 6 trigonometric ratios. Then here also will be 6 answers. Okay. This will be a complete question. Find all the trigonometric ratios of angle A and C. Okay, but the question is, in triangle ABC, right angle at B, then put like this, right angle at B. Then where A and C are put? A and C you can put anywhere. Okay, then put here A, then I'll put here C. Then A, B, C. Triangle ABC. Okay, then look from this figure. What is given? AB. AB is how much? 8 centimeter. Then BC is how much? 10 centimeter. Then hypotenuse? No. Here the question is mistake. Okay, this BC should be something 6. BC here will be 6. Okay. Now it will be correct. AB is equal to 8 and BC is equal to 6. Then find all the trigonometric ratios of angle A and C, but that this AC is not given. Then if it is given, then that will be good. but here it's not given, then you have to use this formula. We have to find this one. What is this? H. I have to find this. Then, okay, leave that one. Okay, I put generally this will be as a perpendicular, then this will be as a base. Generally. When we find this trigonometric ratios, then this 2 will be changed. Okay, this 2 will be changed when we find this TI. But right now, let me consider this will be the perpendicular, then this will be the base, then this obviously will be the hypotenuse. Okay, then solution to that is given. If you don't understand, then you can give a comment, then I will explain it. Okay. Given, what is given here? Given AB is equal to 8 centimeter, then BC is equal to 6 centimeter, but AC is question mark. We don't know, then this will be as H hypotenuse. Okay, to find this H, we have to use which formula? Pythagoras. To find the value of H, we'll use Pythagoras formula. Okay, we know hypotenuse square is equal to perpendicular square plus base square. This is by using what? Okay, we don't need to write. We know this by using Pythagoras theorem. By using Pythagoras theorem. Look, if this sign also is given, then we don't need to use this formula anymore. Directly will find this. If they already given this one, if all the sides are given, then directly will find the R. But here one side is not given, that's why we have to use first Pythagoras so that we'll get that missing side. Okay, hypotenuse. Then I take this square to the right side. Take this square to the right side, is always changed to square root, this everyone will know, right? Then P will be how much? According to this figure, P will be as 8. Then B will be as 6. Then here we got 8 square will be how much? 8 square will be 64 and 6 square will be 36. Then total will be how much? 4 plus 6 will be 10, 10, 10, then will be 100. Okay, then here we got how much? 100. And therefore we get the value of H as, therefore H as how much? H will be the AC. What's the square root of 100? Square root of 100 will be 10 centimeter. Because look at this, 10 into 10 is equal to 100. Now we got the value of H. What is this one? How much we got now? 10 centimeter. Now we got up to here. Okay. Then now we'll come to this trigonometric ratios of angle A and C by using this formula. We got all the values all the side. Then now I'll drop this one. Then I'll drop this one. Okay. Now first we'll start with respect to angle A. Okay. First we'll start with respect to angle A. Then after that we'll go with respect to angle C. Okay. Now, trigonometric ratios. Trigonometric ratios of trigonometric ratios of angle A. Okay. I'll draw all this. Now, look, all the sides we have got. Then in your question exercise, in A question 1, all the sides are given. Then you don't need to use this formula directly. You will jump on this formula like this. Okay, trigonometric ratios of angle A. Okay, angle A. Angle A. Where is angle A here? Here is A. Then let me put this angle. Okay, with respect to angle A. Now, if this is the angle where it's a perpendicular, before we have shown, if here is the angle, then this will be the perpendicular, then this obviously will be the base. But here the angle is, according to this question, according to this, we have to take angle A here, then this will change to perpendicular, and this will be changed to base. Because this one we cannot change. Hypotenuse will remaining there because it's always opposite to 90 degree and always it is greater than perpendicular, greater than hypotenuse or greater than base. Okay, now first we'll find this. 1, 2, 3. Once we get this, then this just reciprocally we'll get it. Okay, now sin theta, number 1. Number 1. Now sin theta. This theta is the angles. Then here what is angle? Here is angle, angle A. Then I'll put here sin A. Here theta is this theta is angle. But here angle is A. Then I'll put here sin A. Then sin A is equal to, what's the formula? P by H. Some people have. Then sin A will be perpendicular by hypotenuse. Now so perpendicular here, perpendicular will be 6 and hypotenuse will be 10. Then put here 6 by 10. Then what's the answer here? We can cancel it, right? Then 2 into 3 is 6. Then 2 into 5 10. Then we got here 3 by 5. Now we got one ratio. Then number 2. Number 2 sin A. Then number 2 will go to cos B. Not cos B, still we are doing sin A. Then here will be cos A. And that will be B by H. Now what is B here? B here will be A. Now again H will be 10. And here will be 2 into 4, 2 into 5, and we got 4 by 5. Now we got cos. Then again we'll come to tan. Number 3. Then tan A. Then again tan will be what's the formula? P by B. Now P here is how much? P is 6, then B will be 8, then we got here 6 by 8, 2 into 3, 2 into 4, then we got 3 by 4. Now we got 3 trigonometric ratios, but how many are? Now still these 3 left. Then for this 3 you don't need to calculate again, just like that is 1, 2, 3, then I put here 4. Then 4 that will be what is cosec. Then in place of this theta, we'll write what is angle A. Then cosec will be, what is the formula? Here is P by H and here is H by P. Then that will be what that is 3 by 5. Then here will be 5 by 3. Then this cos A, then here will be sec A. Then this will be 5 by 4. Then this will be tan A. Tan A, there will be cot A. Then this is 3 by 4. Then here will change to 4 by 3. Now, this will be the trigonometric ratios of angle A. Now we got this one, angle A. Now how many answer? 6. Then we need to find trigonometric ratios of angle C. Here also there will be 6 answer. Okay. Then now we come to next. Trigonometric ratios of angle C. Then I'll change here with C. Then I'll put here. I'll change all this. I'll change all this. All this. All this. Then this one will also will get changed. Then here will change to angle C. Then here also put C, C, C. Okay. Now this will be no more. This is finished. Then we'll change to which angle? Now this angle. Now if this is the angle, with respect to this angle, which one is the perpendicular? This will be no more the perpendicular. Now the perpendicular will change to this one. Now this will change to perpendicular. Then this will change to base. Now this will change to base. Now again same formula. Sin C will be P by H. Now what is P here? P will be A. then h will be 10, then you got here 4 by 5, then here b, what is b here? 6, then you got 6 by 10, then that will be 3 by 5. Okay, can you complete this by your own? Can you do it? And show and send me in the personal group, okay? Okay, can you try question number 1 and question number 2? Okay. Exercise 8A. Question 1 and 2 will be HW. You do it, this question 1 and 2, and send me in personal WhatsApp number so that I can check your whether you understand it or not. Okay. Then now we'll come to next type of problem, one more. Then that last question I'll do for you. Then that's it for today. Okay, next question. This is the question. Then after listen carefully, I'll solve this question for you and you try question from your exercise 8A, question number 3. Okay, this is question solution. Now what we need to find? We need to find here, find the remaining trigonometric ratios. Find the remaining. How many all of them? There are 6 and 1 is given here. 1 is given, then what left? Now we need to find how many? 5. There are total how many? 6 ratios. 6 trigonometric ratios, but 1 is already given. Then we need to find how many? 5 left. Okay, how to find this one? This is very simple, again by using Pythagoras. Okay, solution given. Given tan theta equal to root 3. Given tan theta is equal to root 3. Now this one I can write like this. Tan theta equal to root 3 by 1. Because 1 we can write from below. Because root 3 divided by 1 will be root 3. Then this I can write as, what's the formula of tan? What's the trigonometric ratios of tan? Tan will be torn permanently. Then that will be tan is equal to P by V. Tan is equal to P by V. Then from here compare this. Compare this. Look, this tan is equal to root 3 by 1 is a given from the equation. Then tan theta is equal to P by V is from the formula. Then here, P is equal to this P, perpendicular. Perpendicular is equal to root 3. Then base is equal to 1. Then what is missing? Hypotenuse, which is missing. Then again, by using what? By using Pythagoras theorem or Pythagoras formula. Then h, I will use that h is equal to root p square plus b square. Then p here is equal to root 3. Then plus b is equal to 1 square. Then how much we got here? Then root 3 into root 3. Root 3 square is equal to root 3 into root 3. Root square. Root 3 square. Root 3 into root 3 is equal to how much? 3. Because this square and this root are cancelled out. Because this root I can write as like this. 3 to the power 1 by 2. This I can write like this. Because root is equal to 3 to the power 1 by 2. Then 2, then 2 and 2. Cancel and one left here. Only 3. Okay, then here we got 3. Then 1 square will be 1. Then how much we got? 4. Then the square root of 4 will be 2. Now we got the value of h. Now we got one. Now P we got, B we got, and H also we got. How much? 2. Then D does the remaining TR. Okay. Remaining TR. Okay, I'll put with 1. I'll start with what? With sine. Then sine theta. Sine theta is P by H is a formula. You check from the formula. Sine theta is equal to P by H. Now how much is P here? P is root 3 and H is equal to how much? 2. Then I put here root 3 by 2. In place of P, how much we got? Root 3. And in place of H, how much we got? 2. Then I'll write again here this directly cosec. Cosec theta will be reversal of this, right? That is H by P. Then here will be 2 by root 3. Then number 2, that will be cos theta. Then that will be B by H. Then what's the value of B? B here is 1. Then H here will be 2. And put 2 here. Then sec theta. Then sec theta is equal to again reciprocal of this. That will be H by B. Then that will be 2. 2 by 1. 2 by 1. Then this will be equal to 2. Okay. The next. Now number 3. Number 3 will be tan. Tan is this one. Tan we already have. Then what left? Cot. Then cot theta is equal to B by P. Because cot is the reciprocal of tan. Cot is the reciprocal of tan. And here I'll write B by P. B here is 1. Then P there is root 3. Now how many? 1, 2, 3, 4, 5. Okay, I can write this as one. This will be number 4. Then this will be number 5. Now find the remaining trigonometric ratios when tan theta is equal to 3. Then 1 is given. Then how much left? 5. Then the remaining are this one. Then we got the answer. Then this will be helpful for you to exercise 8A, question number 3. Question number 3. There are so many are there. 3, 1, 3, 2, 3, 3. Then you can try which one you don't get the answer. Then send me in the personal WhatsApp so that I can check where is your mistake. Okay. Okay. Thank you for today.